Hey folks, it's Stefan here. This is a tutorial video for GameMaker Studio 2, and I'm going to be showing how to perform smooth room or screen wrap of a sprite as shown here in my game 8-Bitoids. And right now, because of where the asteroids are, you can see that they're wrapping vertically. For this tutorial, we're going to show horizontal and not vertical. They do wrap horizontally as well, but since they're all heading toward the middle of the screen right now, it'll be a while before you see that. But basically, as the object is going off of the screen, we want to start drawing the part that's off the screen at the left or right edge of the screen instead of just disappearing. So we can get rid of 8-Bitoids here. And we're going to go to a new GameMaker window. We're going to make a new project here called Smooth Wrap. And the first thing that we need is a sprite. So let's create a sprite. SPR shape. I'm just going to make something that's kind of diamond shaped. So somewhere in the middle. Somewhere in the middle. Hopefully this is mostly in the middle. Alright, so there's our diamond shape. And then we're going to, whoops, I didn't want to change the color of it. I wanted to change tools. Okay, so we're going to keep that shape, and then we're just going to split it down the middle with a line. So I guess it wasn't quite in the center, but that's all right. And then we're going to fill in one side of it with this color. And this will more easily allow us to see which side that we're actually working on. So we're going to close that. We're going to set the origin to middle center, and we need to make ourselves an object. So obj shape, and we will set this sprite to be our sprite. And so we're going to make a change to the room. I'm going to make the room smaller and set a view on it so that it gets scaled. So we have a default room, and I'm just going to make this 320 by 240. I'm going to enable viewports, and then make this first viewport visible, and we're going to set our camera position to be 320 by 240, so show exactly what's in the room. And then our viewport is going to be 640 by 480, so it's double the size. So it'll just make it easier to see. Alright, and then we're going to drag our object in here and put it in the middle of the room, and that is all we need to do in the room. And we don't need the sprite anymore either. Alright, so first thing is I would like to show you that GameMaker already supports screen wrap. It's just not the screen wrap that we want. So first let's add some motion to our sprite. So we're going to do motion set. 0 is the direction we want to head to the right. So in GameMaker your angle 0 is to the right. And we're going to set a speed of 1. So if we were to run this the way that it is right now, our sprite would go from the center of the screen to the right, and then it would just disappear. We wouldn't see it again. So we want to wrap that. So we're going to come into the step event, and we're going to say move wrap. And then this takes 3 arguments. So we've got horizontal. We do want to wrap horizontally. We're not going to bother wrapping vertically. And the margin is how far off of the edge it is before it wraps. So we're just going to leave it at 0. So when it hits our origin point of our sprite, that's the point at which it will wrap. Alright, so we'll just run this quickly so you can see what the effect is. And there's our sprite heading off, gets to the middle, boom, pops into the other side. So it just snaps from one edge to the other, instead of drawing the part that has disappeared off the screen onto the other side, which is what we want to do. So what we're looking to do is draw the object so that it smoothly wraps. So we're drawing pixel by pixel onto the other edge of the screen, whatever part is no longer visible on the other edge. So to make it easier to do the development and debugging for this, we're actually going to tie our sprite to the mouse movement first, and we'll turn this off eventually. So we're going to set up a variable is mouse follow equals true, and then we're going to make a conditional if not is mouse follow, and then we'll still do the motion set. We don't need it in motion when we're following the mouse. And then we're going to do the same thing in here. So we want to wrap this. If not is mouse follow. Then we'll do this. Otherwise, we do want to do the mouse follow. And so to do that, we need to set our X and Y position of our sprite to whatever the mouse is set to. Okay. But when it goes off of the edge, we still want it to snap to the other side so that we can see that our code is doing what we expect. So we're going to handle that case. If mouse X is less than or equal to 0, X equals room width plus mouse X. So our mouse X is a negative value, so we're going to say whatever the room width is plus that negative value will put us from the room width edge further into the room. And then we need the other direction, not room. Mouse X is greater than or equal to room width, then X equals mouse X minus room width. Okay, so if we run this now, you'll see that we can move our sprite with the mouse. Okay, and if we get there, it snaps just the way that move wrap did. So we get to the edge, it snaps just exactly the same, and we can move further. Okay, so this isn't probably a control mechanism that you'd want to use in an actual game, since it's, you know, it's not really connected to the mouse as soon as you keep moving your mouse off the edge. But for now, it'll work. It's fine for our purposes. So the draw event is where we're going to be doing the sprite splitting. So we need a draw event. And first, we only need to do this if the sprite is actually not fully in the room. So let's set up a conditional to determine if that is the case. So sprite width divided by 2 is greater than room width, or X minus sprite width divided by 2 is less than 0. Okay. So if that's the case, we're going to draw parts of our sprite. Draw sprite parts. And if it isn't, then we can just use draw self. So just keep doing what it's doing already. So if we were to run it now, really nothing would appear any different because we're not setting up the draw parts. But what would happen is, since we're not doing anything in this conditional block, as soon as we move outside of the room, we're just not going to draw anything. I think you can understand that without me showing it, but I'm going to show it anyway. All right, as long as we're in the room, we draw fully. As soon as we go outside of the room, and then now we're determining the whole area of the sprite. So as soon as we get our point there of our bounding box, it goes out. Okay. So what we're going to be using is Drawsprite part. So we're going to look at the documentation for that. Let's bring up a documentation window and Drawsprite part. And with this function, you can draw a part of any sprite at a given position within the room. So it takes many arguments. So obviously the sprite that we want to draw, the sub-image of that sprite or the frame. We're not going to concern ourselves with that because our sprite only has one frame. But these are the ones that we need to keep track of. So the left is the X position of the sprite of the top left corner of the area to draw. So where in the sprite do we want to be drawing the top left corner? The top is the same, but it's, you know, it's the top, it's the Y value. Then we need width and height. So inside of the sprite, how wide of an area do we want to draw? How tall of an area do we want to draw? And then where do we want to draw it? So these are 6 values that we need to keep track of. We could just do that in local variables, but it's easier to set up a struct that will keep track of these for us, and probably a better programming practice as well. So we're going to make a script. We're going to call it sprite part. And I'm just going to remove this scr that it puts in by default, because you can have multiple functions inside a script. Now we want this to be a constructor because we're making a struct here, so we have to put constructor on. And we're going to put all of the values that we're interested in keeping track of. And just by convention, I'm using underscores for local variables, and an argument passed into a function is a local variable. So we're going to do underscore x, and then we're going to give a default value for all of these. So we don't actually have to provide these values if we don't want to. If we just call new sprite part, it will default all the values for us. So we have to do x and y. We need left. We need top, width, and height. Okay, so that gives us our arguments to the function, and now we're just going to set all those to the variables inside of the struct. All right, so now we're able to track those 6 values that we're interested in. Now a useful thing for debugging is to have a toString function inside of the struct. So this actually is defining a function that's an element of the struct. And then when we pass the struct as an argument to the string function, it will call this and it will format this for us. So I'm actually just going to copy this from code that I've already written so that you don't have to watch me try to type this whole thing out on screen. But you can pause if you need to see what it's doing. Basically, we're saying toString equals function, and then we're just going to return a string that we're building up of the various values that are inside of our struct. So now we can go back to our draw function, now that we've got our struct set up. And outside of here, we're actually going to set up some variables. X minus sprite width, divided by 2. So this is our x1, this is our left edge. x2 is going to be our right edge of our sprite. Remember that our origin's in the middle, so that's why we're subtracting half of the width and adding half of the width. We also need to know what the top y is. Since we're only doing horizontal movement, our y is not going to change, but we do need to know what it is. So we're going to do y1 equals y minus sprite height divided by 2. Okay, and with these variables, we can actually make this conditional check easier because it's pretty complex right now. You don't really want to get into a conditional that's that long that you have to read through every time that you want to see what it does. So we're just going to chop that out. I'm going to say if x1 is less than or equal to 0, or x2 is greater than or equal to room width. So now we're going to draw the parts of the sprite if we've been split. So we know that we're either off the right edge or we're off the left edge. So we're going to set up a local variable, 2 local variables to keep track of the parts, and we're going to do this using our new struct. So sprite part, and we're going to pass x1, y1. So that is going to be our new x position for this sprite part that we're drawing. We're going to say 0, 0, so that is the top left of our sprite. We're going to say sprite width divided by 2. And then we want to draw the whole sprite height for each side, so we're just going to sprite height. And then we're going to set up the one for the right side. New sprite part. Now here, we're going to be x1 plus sprite width divided by 2. Okay, we could also have just said it was whatever the left width was, but we need to calculate this every time that we come into the draw event, so we're just going to do it this way. And then y1, our y position is always going to be the same. And then we want to set our top left to sprite width divided by 2. So halfway across the sprite, we're going to set our 0 for our top position, and then we're going to set sprite width divided by 2 as our width, and again keep sprite height for our height. Alright, let's make this longer so that you can actually see it. Okay, so there's the whole thing. If you need to pause to copy that, go ahead. Alright, so these are the defaults that would split our sprite equally in half. Now this is not really going to be the case very often, but they're reasonable defaults to use. Now temporarily what we want to do is use Drawsprite part ext instead of Drawsprite part, because the ext allows us to color blend the part of the sprite that we're drawing, and that will just help us with debugging. So let's put in our draws here. Drawsprite part ext. Sprite index and image index are the values of the sprite that we want, so there's only one frame, so image index is going to be 0 there. And now we're going to reference all the values in our struct that we need. So left top, left width in the order that they're needed, of course, which is different than the order that we actually created them in the struct. Left.x and left.y. And now we have to provide this 4 other parameters for the color. So let's make this wider yet again. The first 2 are scale. We don't want to change the scale, so that's 1, 1. We do want to change the color though, so we're going to make our left side red, and we're going to set an alpha of 0.5. We don't fully want to obliterate the color that's already there, so we're going to just do 0.5 for alpha, because remember that we put in that dividing line to see which side we're working on. Drawsprite part ext, and this is going to be exactly the same, only it's going to be the right side. So, and well, it's not exactly the same, because we're going to use green as the color here. Okay. So this is going to make whatever we're drawing as the left draw in red, and whatever we're defining as the right draw in green. And this will help us to see how we're actually splitting the sprite. So if we run this right now and move left, or move off to the left edge or to the right edge, you'll see this shape is drawn half in red and half in green. So let's just illustrate that. Okay, so we're not actually doing any sprite splitting right now. We've just split it in half. So, but you can see as soon as we begin to go off, now we're drawing half of it in red and half of it in green. Okay, it doesn't matter which side we go off, it'll do the same thing. Okay, because we're going into that conditional block. So now we need to do the actual calculations to figure out what part of the sprite should be the left part and which part should be the right part based on our position. And we'll start with the left edge. So when an object is moving off of the left edge, we'll be defining a left side that will be drawn on the right side of the screen, and the right side will continue to be drawn on the left. So unlike above where we defined left and right, will no longer be half of the sprite. We're going to be portions of the sprite. And as we move to the left side will get smaller, and but then it will grow as we continue to move, and the right side will initially become large, but it'll shrink as we continue to move. And I don't know if that's a good description, but you will see it here in practice in a moment. So now we need to do the calculations to figure out which part of the sprite should be the left part and which part should be the right part based on our position. And we'll start with the left edge. So when an object is moving off the left edge, we'll be defining a left side that will be drawn on the right side of the screen. So the left side of the sprite, but it's going to be drawn on the right side of the screen. And the right side of the sprite will be continue to be drawn on the left side since we're moving off the left edge. So it's whatever's remaining as we're moving off the left edge will stay on the left edge. So unlike above where we defined the sprite to be split in half, we're actually going to change what left and right refer to. So as we move left, the left side will initially be quite small, but it will grow as we move further off the left. And the right side will initially become large, basically the whole sprite, and will shrink as we continue to move. So I'm going to put the code in, and then I'm going to explain what the code does after the fact. Our left x is going to be the room width plus x1. So x1 is a negative value. So we're drawing in from the right edge. So we're saying right edge minus whatever this x1 is. The rest of the values, aside from width, will stay the same. We're still interested in the left side of the sprite and for the entire height, and we still want the same y position on the screen. Width becomes ABS x1, which is the absolute value of x1, which just removes the sign. It was the negative number, now it's positive. As we move further to the left of the left edge, the wider the left portion of the sprite becomes. For the right side, our x becomes 0, and will stay 0 until the step code changes the x of the center of the sprite to be the right edge. So we're going to continue to draw at 0 for the right edge until we're switching sides and drawing it onto the other side. The left of right, though, the leftmost position of the original sprite that we consider our left edge is ABS x1, again taking how far off the left edge we are and making it a positive value. Finally, the width is sprite width minus left width, where we've already defined how wide the left side is, so we know the right side is the remaining portion. So if you run this now, and you move the sprite to the left edge, you'll see the whole thing turns green, but there's no red. Why is that? That's because the sprite contains some areas outside of the shape that we drew that are alpha 0 or transparent. So the left is being calculated and drawn, but what we're drawing is transparent. As you move further left, you'll see the red portion of the sprite on the right edge of the screen, and you'll also notice that if you go as far left as the middle of the sprite, that it stops drawing anything on the left edge, and that's because we are changing the position of the sprite to wrap around the room, so the conditional above is x1 less than equals 0 is no longer true, and therefore that code's not being run. So to fix that, we're going to handle the opposite case. But let's just do this example first. Let's just show you how it looks. All right, here's our sprite, not doing anything weird, and boom, everything turns green. And we're not drawing anything in red. But as we continue to move, now you can see it start coming in on the other side as red. All right, there's about half the sprite, and as soon as we hit this origin point, we're going to stop drawing here, but we will continue to draw on the other side. Okay, but what we need to handle is that case in between those 2 points. So we're continuing to draw what's on this side. Okay. So this is going to be another block of code that I'll put in, and then I'll explain what it's doing. Okay, and if you want to pause here so that you can see that block of code, as I continue to move the screen around to make it harder for you to do. For the left, the only thing that we need to change from the default values, which are calculated each time that we come in here, remember. So if we go back here, we are calculating this left and right each time. Right, when we're making a new struct. So the only thing that we need to change in this case is the width, to which we set to sprite width minus x2 minus room width, or the difference of how far off the screen's right edge we are, subtracted from the full sprite width. So as we move toward the right edge, left will initially be most of the sprite, whereas right will be a small part of it, just the reverse of what was happening on the other edge. So right x now is going to be 0, and we want to draw the right side of the sprite starting at the left edge of the screen. So that's why we're setting it to 0. The right left is the left width, which is everything beyond the right edge of the screen, and left width, and then finally right width is the remainder of the sprite width minus left width. So hopefully that's clear. You can look at this code to understand it more. All right, so if we run this now, this will work the way that we expect. So we have smooth wrapping in both directions. So now we're moving off the left edge, and we can continue to move until it's completely on, no longer split, right? So we're seeing a nice smooth drawing of every pixel, every column as we do that, and then the reverse will work as well. you go. So that is splitting across there. So now we want to go back and remove the ext part. So we don't need ext anymore because we're not really using that color to see that anymore. We just want to show what the sprite is. This is really just temporary to help us see if there was a problem. So we'll just remove these arguments and make it a Drawsprite part. And if we go back to the create event, we can disable the mouse follow because we're not mouse following anymore. So we're just going to make that false. And of course, the original wrapping code is going to happen as well. So let's run that now. Now remember, we're only moving toward the right, so this will always go in the same direction. But it will smoothly wrap, so it's using the exact same code that we put in for the draw, but now with the existing motion stuff, so it's doing a nice wrap as we move across that edge. Now, just for completeness sake, let's put a way to turn this so that it can start moving in the other direction. So we're going to do key pressed, and we'll do a letter, we'll do R, and then we're just going to say direction plus equals 180. So we want to go in the opposite direction from what we're heading. We know we're heading in direction 0 right now. 180 is the opposite direction. And if we add 180 to that again, to go back in the right direction, it would go to 360, but GameMaker automatically constrains that for us, so it's going to go back to 0. So we can bounce back and forth. So we'll run this, and when you press the R key, it will change the direction. So we'll wait until it gets off the screen here. That's off the screen. Now let's go back in the other way. And you can do this when it's split, and it's not going to cause any problems. All right. So if you want vertical wrapping instead of horizontal, the process is going to be much the same, but you'll be doing the top and bottom halves of the sprite and concerned more with Y positions than X positions. And to handle both horizontal and vertical, it gets more complicated. And you need to split the sprite into 4 quadrants. So you're drawing 4 possible parts of the sprite. And then there are actual corner cases that need to be handled. So I hope you found this video helpful. I know it was a bit long and involved, but I hope it was clear. If you liked this video, please press the like button. And if you want to see more GameMaker tutorials, please subscribe to the channel. If you have any questions or comments, I look forward to reading them, and I will try my best to answer them. If there is enough interest, I may post this project on itch.io so you can just download it instead of following along the video. Please do let me know if you'd like to see more GameMaker content, and if you've got suggestions about what content would be useful to you, let me know. Alright, thanks for watching, and happy game making.